Welcome, welcome, welcome. People are here. Oh, yeah, someone joined. That's cool. Welcome, welcome. Pull up the problems. We'll get started at like 9:05 as we usually do. Oh, another person joined. That's cool. Hopefully you can all hear me okay. I guess I should pull up my calculator as well. Let me mess with that. There. Just gotta remember where it is on the screen so I don't like right underneath it. All right. Again, we'll wait till 9:05, then we'll get started. Oh, one person left. That's too bad. Kind of early over here on the West Coast. All right, let's see who we get by 9:05. All right, it's 9:05. Let's get started. There's only one person watching. That's fine. The hope is to make these into videos, but all right. Let's make sure this is visible. Yep, that's pretty good. All right. Water is being pumped into a tank at a rate modeled by whatever liters per hour. We have to measure in hours. So I pretty much already want to throw that into my calculator somewhere. Water is removed from a tank at a rate modeled by R of T liters per hour. So this is an entry and exit problem. Those are pretty common for number one. Oh, by the way, this is BC 2016, if people care. All right, estimate R prime of 2. I guess I don't need to throw in W into my calculator yet. R prime of 2, that should just be, this is a common approximation. That's just R of 3 minus r of 1 over 3 minus 1, right? The average rate of change on that interval, which is this guy, should be pretty close to the instantaneous rate of change halfway through the interval. Let's see what that is. R of 3 is, on my calculator now, 950, and then we subtract off 1190, and then we divide by 2, negative 120. What are the units of measurement? Well, it's liters per hour, but then we divide it by hours, right? The top is liters per hour, the bottom is hours. So liters per hour is fine. You could probably say per hour squared, and it's okay. All right. Use a left Riemann sum with the 4 subintervals indicated in the table. Sometimes people are confused by what that is. It's these subintervals: 0 to 1, 1 to 3, 3 to 6, and 6 to 8. To estimate the total amount of water removed from the tank during the 8 hours. Is it an underestimate, and given a reason? Okay, so left Riemann sum for removed. All right, so we just do, this is A, B is going to be 1340 times 1 plus 1190 times 2. Why times 2? Because the gap here is 2. And it always looks like this kind of shape for left Riemann sum, plus 950 times 3 plus 740 times 2. Okay, and then let's see what that ends up being on my calculator in a second. All right, so you have 1340 times 1 plus 1190 times 2 plus 950 times 3 plus 740 times 2. 8050. Is this an over-under estimate? Well, the water is removed by r of t, and that's a decreasing function. So if you're doing a left Riemann sum on a decreasing, I guess, continuous function, then what is that? That is an overestimate, right? Because it looks like this up there. Overestimate. I guess I'll say left Riemann sum over S decreasing functions. All right, part C. Use your answer from part B to estimate the total amount of water in the tank to the nearest liter at the end of 8 hours. Well, the total amount of water in the tank, I'll call that A of T. What do I know about A of T? Well, I know, well, it's, I keep saying a number. It's amount of water in the tank. What's A prime of T? Well, that's the entry minus the exit, so W of T minus R of T. And I know A of 0 is 50,000 because it says so up here. All right, now the net change theorem, or FDC, or whatever you want to call it, says that A of T is 50,000, so that's A of 0, plus the integral from 0 to T of A prime of x dx, or whatever. That's W of, I'll call it S, minus R of S ds. In our case, we want A of 8. So A of 8 is 50,000 plus the integral from 0 to 8, W of S minus R of S. And I'm going to break up the integral. It's at 5, not 6. Zero to 8 of W of S ds, which I can calculate on a calculator. and then minus the integral from 0 to 8 of r of s, which I just approximated in part B. And then on my calculator, that I guess now I'll dump in W because I need to at some point. What is W? 2000 e to the negative, oops, not divided by, e to the negative x squared over 20. All right, we're going to math 9 from 0 to, what was it, 8? That's what I said. Oops, not 0, 8, 0 to 8 of y1. All right, so this is 50,000 plus, calculator tells me 7836.195. And then I subtract off this 8050 I found beforehand. And that is 49789.195 or something. Nagging feeling that's wrong, but we'll check. 6.195. Always give 3 decimal places in your answer. That's actually why I rounded this to 3, right? All right, part D. That was C. Oh, sorry, to the nearest liter. Gosh, reading, Riley. There. Okay, D. For 0 less than 2 less than 8, is there a time when the rate at which water is pumped in the tank is the same as the rate at which water is removed? All right, so is there a time question? It's almost always MVT or IVT. In this case, I know a good amount about the rates. So you might think that's MVT, but it's actually IVT, right? Because MVT tells you something about the derivative. I don't care much about the derivative of the rates. I care about the rates themselves. So it's probably an IVT problem. So I know R is differentiable, so it's continuous. It starts at this number, ends at this number. Probably what you want to do is look at the difference, right? So maybe I'll do it fancy. Let delta of t equal, say, W of t minus R of t. R is continuous, bar here. R is continuous because it's differentiable. W is continuous. This implies delta is continuous, because delta is a difference of two continuous functions. Let's see. And then delta of 0 is W of 0 minus R of 0. W of 0 is 2000. R of 0 is 1340 or whatever. I'll just calculate that. So I can do, I know it's 2000, but whatever. Y1 of 0 minus 1340, 660. That's greater than 0, and that's greater than, hopefully, greater than, hopefully, delta of 8, right? It tells you the interval, so probably should use that. It's a good starting point, at least. Well, what's delta of 8? That would be W of 8 minus R of 8. And that is this guy, which is, I'll just say it's greater than, yeah, W of 8 minus R of 8. There. This inequality, especially the underlined pieces, tell you by IVT. I guess I should say these continuity things are all continuous on 0 to 8. Well, IVT, there is a point C in 0 to 8 such that delta of C equals 0, and that implies that W of C minus R of C is 0, and that implies WC is RC. That one might be a bit confusing. It is best to make this new function. To find out when two functions cross, it's probably better to look at when the difference is 0. Okay, I guess I'll check my answers on this. Give me 1 second. Oh, I'm actually on the wrong year. Is BC or AB? Is it different? Oh my gosh. I'm looking at the AB stuff. Give me 1 second. I bet it's the same, but let's see. Good, it is the same question. And no, that's all right. Yep. Okay. All good. Let's keep going. Question number 2. This might be different for A, B, and BC, but now I'm actually looking at the BC one, so... Oh, this question's a pain. Or it's easy to do it wrong. All right. At time t, the position of the particle moving in the xy plane is given by that parametric function. This is some kind of parametric thing. They tell you dx/t, they tell you y, which is kind of weird. It's unbalanced, right? They give you dx/t and they give you y. And then at t equals 0, the particle is at position 5, 1. All right. Find the position of the particle at t equals 3. Well, I know y of 3 is just negative a half, because the graph says so. I mean, okay, why is that exactly negative a half? It's a line. I mean, do whatever you need to do, but it's negative a half. And then what's x of 3? Well, I know from the net change theorem, which is just FTC, it's x of 0. Why am I picking 0? Because I know information about 0, plus the integral from 0 to 3 of dx/dt. I guess I should dump this in my calculator at this point. Oh, because this is visible. Let me make sure I'm looking okay. Yeah, it looks fine. All right, back to where I was. So I would just dump in x or dx/dt into your function mode. You could do the parametric mode, but I think it's better to do function mode here. It's just easier. Whenever you see a sign, you should always, like, at the beginning of the test, you should double check to make sure you are in radians mode. I don't have much excuse to not be in radians mode nowadays. So that's good. But people taking physics do, so. All right, or it should be in degrees mode, right? Okay, well, x of 0 is 5, so 5 plus math 9, 0 to 3, alpha trace y1 dx. It takes forever. It tells me it's 14.377. So there we go. Position. I'll say x of 3, y of 3 equals 14 point whatever that was, 377, comma, negative half. Cool. All right. Find the position of the particle. Sorry, find the slope of the particle. Sorry, slope of the line tangent to the path of the particle at t equals 3. So that's just dy dx at 3. And dy dx is dy dt over dx dt. So dy dt of 3 is positive a half, because the slope is positive a half. Notice this is y, not dy dt. And then dx dt at 3, we just go to my calculator and just go alpha trace, not alpha, yeah, y1 of 3 Apparently it's 9.956. I'll just leave that as is, but I'll write down 9.956. And then you divide and get something. So you divide a half by that. dy at t over dx dt is 0.0502. All right, that's probably already too many decimal places, but there we go. All right, part C, find the speed at 3. That is just root x dx of 3 squared plus dy dt of 3 squared. And the square applies to everything here. Like that. All right, and we go to my calculator. Notice that dy dt of 3 is a half still, so that's fine. So it's just this number squared plus a quarter, and then square rooted. All right, 9.9689. Right, hopefully that's right. Let me think for a second if I did something silly. That should really be it. And then D is kind of an awkward problem here. Find the total distance traveled from 0 to 2. You want it to be this integral, right? The t dt is the integral from 0 to 2 of the speed. But the problem is that dy dt is like weirdly piecewise. It's also 0 to 2, right? So it chops off here. So I'm actually going to break it up into two integrals. 0 to 1 of dx dt squared plus the slope here is -2. So 4 was when it's squared. I'll just write out -2 squared. And then plus the integral from 1 to 2 of root dx dt squared. Because dy dt is 0 on 1 to 2. dt's here, and we go into my calculator and plug these in. Math 9, 0 to 1. Square root of y1 squared plus 4. Plus 1 to 2. And you probably do want the square roots here still, and just in case there's some negative. There's a negative that makes it positive, so just, you could say absolute value if you want to, that's fine as well. 4.350. That seems wrong, just from memory, but my memory's not so great. Okay, I guess I'll check this in a second. Let me double check my calculator said that. Yep. All right, let's see what it is. -0.05, 9.96, 5.35. Yeah, okay, I guess it's all good. All right, we'll go on to the next one shortly. Let me turn off my calculator. Okay, it's gone. All right, let's go on. Question number 3. And our calculator, of course. Let me pull it up, actually. Oh my gosh, where is it? Here it is. The figure above shows the graph of the piecewise linear function f. Okay, g is defined by that integral. Does g have a relative max, min, or neither at 10? Okay, well, g prime of x is f of x by ftc. It is actually important that f is continuous. But, all right, and then at 10. Well, let's see. So this is the graph of f. Should be neither. Neither, because f doesn't change sign. At 10, which implies that G doesn't, say f like which equals G prime, doesn't change sign at 10, and that implies that G doesn't change direction. So no extremum. An extremum is a change of direction. I don't know if direction is a well-known word on the AP test, so I'll say increasing, decreasing. All right. From my experience, they typically are okay with just this first part, but I would do the whole thing. Okay, B, does the graph of G have point of inflection at 4? Yeah, it does. Yes, because F changes direction, changes, I'll say, from increasing to decreasing. And thus F prime changes from negative to positive. They're usually okay with just this first part, but I'll say this again, changes from, say, positive to negative. And so G changes concavity at 4. So by definition, because the definition of point of inflection is usually a change from cavity. G has a point of inflection. And I know I'm super wordy. I might also say, remember that F is G prime and F prime is G double prime. Okay, find the absolute min and the absolute max on the interval -4 to 12. All right. So here you got to check your critical points and your endpoints. And you might become annoyed. It's like, oh my gosh, there's 4 critical points. However, we are, you only need to check the ones that are local extrema. So -2 and 6 are the only local extrema. So you can actually say that. We may skip checking what was it? 2 and 10. Because they are not local extrema. I might say G prime doesn't change sign. All right, so you just gotta check the other ones. Mins and maxes, I guess. All right, so make a little table. -4, -2, 6, and 12. And this is annoying. So G of -4. That's an integral from 2 to x. So, all right. G of -4 is the integral from 2 to -4 of f of x dx. And that's negative the integral from -4 to 2. I always, in these kind of problems where you're finding area from a graph, I always do the integral from bottom to top. So even if I have to swap it around. How much is that? Well, that's going to be -4 to 2. Sometimes as good as going right in the areas. This first area is, let's see, a 2x4 triangle, so that's -4. Then a 2x4 triangle again, that's 4. And then 4. And then 4, 4. Oh, so convenient, everything's 4. 4, -4, -4. And then -4. Awesome, okay. So -4 to 2 is +4. You're like, I just wrote in -4. Okay, there's a negative out here though. So, all right, so we got -4. g of -2 is the integral from 2 to -2, blah, blah, is negative the integral from -2 to 2, fx dx, which is 8. Again, there's a negative up front. G of 6, g of 6 is, am I doing this right? Yeah, okay. G of 6 is the integral from 2 to 6. Don't need to swap that one around. 8. And G of 12 is the integral from 2 to 12. Yeah, the Candace test is always very tedious, I know. 8, -8, -4. So the by Candace test, the absolute min of G do they want the value or the locations? Actually, just the values, but is all the same, -2, -8. I might say the value is 8. The min is -8. And the absolute max. 6.8. All right, cool. Should be good. Candidate's test is a justification. I guess you should say, maybe you should say something like G is continuous on a closed interval. By FTC. It's differentiable by FTC, so it's definitely continuous. All right. For -4 less than x less than 12, find all intervals for which g of x is less than or equal to 0. All right. This one's kind of funny. You can just like say it. So it's 0 at 2, and then yeah, it's actually a little complicated. So it's definitely 0 at 2. And if you go to the left, you pick up some negative area. So it should be negative all the way to the left, I believe. You can kind of do a running area sum. So we know that at -4, it kind of starts at -4. And then you're up to -8 here. This is what G is doing. And then you're up to 0 here. And then you're up to 8 here, and then down to 0, and then down to -4. That can be a helpful way of thinking about it. So you know it's -4, -8, up to 0 at 2, and then it crosses up to 8, and then back down to 0, and then -4. So something like that. So it should be like here and here. So I'm going to say it's at 2 and -4 to 2 and 10 to 12. And I'll explain why. D of x is less than or equal to 0 on -4 to 2 and 10 to 12. Why is this? Notice that g of 2 is 0, and g is increasing on, what was it, -2 to 2? Yep. -2 to 2. So g of x is less than 0 on -2 to 2. So that's one thing you should say. Another thing you should say is that, well, g of -4 is less than 0, and g is decreasing because g prime f is negative on -4 to -2. So g of x less than or equal to 0 on -4 to -2. We also know that g of 6 is 8. Or I guess I don't need that yet. Again, we know g of 2 is 0. And g is increasing on 2 to 8. Is that right? Oh, 6, sorry. 2 to 6. This isn't, I'll show you what they actually want you to say, but it is kind of annoying. Like, this is how you need to justify it. Like, actually, quote unquote. Increasing on 2 to 6, so g of x is greater than 0 on 2 to 6. I'm not only showing where it's negative, I'm showing where it's like everywhere else is positive. Right? And then we also have g of 6 is 0, and g is decreasing. Oops, sorry. G of 6 is 0. No, it's not. G of 10 is 0, I meant. It really doesn't matter what g of 6 is. G of 10 is 0, and g is decreasing on 6 to 10. So g of x is positive on, I guess I should say, technically I should say that, on 6 to 10. And lastly, g of 10 is 0, and g is decreasing on 10 to 12. So g of x is negative, or non-negative, or non-positive on 10, 12. All right, and putting those all together gives you the initial thing. You kind of, I'll just explain why. You have negative 2 to 2 and negative 4 to 2. So those together give you that whole thing. And then we also have 10 to 12 when it's non-negative, sorry, when it's non-positive. And then also I showed everywhere else it's positive. So in particular on 2 to 6, then orange here, on 2 to 6, sorry, 2 to 6 here and 6 to 10, so 2 to 10, it is positive. Okay. And I'm being really nitpicky on that one. Okay, let's check my answers and I'll talk about D, like what they actually want you to say, because I'm being a little bit nitpicky. Okay, let me pull it up here. Okay, function has neither relative nor max. Yep, has a point of inflection. Yep. -2, -8, 6, 8. Yep, got those. Yeah, they just say it. That's just so lame. I don't know. I mean, they don't even give a justification. You just get points to the intervals. It's kind of sad. Right, that's what they say. They say don't do any of the thing I wrote down. Just say that. It's like, okay. All right. Let's go on to number 4. I do want to end at like 9:55 today. So, all right. Let's do number 4. Differential equation problem. Find d squared y, dx squared in terms of x and y. Okay, just differentiate it. Right? Don't forget that derivative of y is dy dx, and then you plug that back in, and you get 2x minus x squared plus half y. Coolio. Done with A. B, let f be the particular solution of the differential equation, whose graph passes the point -2, 8, so we know that y of -2 is 8. Does f of min, max, or neither? Okay, well, to find min, max, neither, you usually do a first and second derivative test. So dy dx at -2, 8 is, let's see, -2 squared is 4. Yeah, so negative 2 squared minus a half times 8, and that's going to be 0. And then d squared y dx squared is going to equal... Notice you can actually use this, so it's a little more convenient because you know this guy's going to be 0. And you can just say that it equals negative 4. Because I'm just plugging in here, basically. And okay, that's less than 0, so justify your answer by second derivative test is max. Cool. And again, why is that the case? Having a negative second derivative means you're like concave down, kind of. That's the idea. So it has a max at the top of a concave down. Concave down is a frown, right? All right, let g of x be the particular solution to the differential equation. Find the limit. Okay, probably L'Hopital's rule, right? So limit x goes to negative 1. Well, let's just check that g of... I mean, technically you're supposed to show this. Limit x goes to negative 1 of g of x minus 2 equals... I mean, g is continuous, so it should be differentiable even. G of negative 1 minus 2, which is 2 minus 2, which is 0. And the limit as x goes to negative 1 of 3 times x plus 1 squared is 0. You might wonder, why am I doing all this? You technically do need those limits to be 0, or both 0 or both infinity, for L'Hopital's rule to work, so you probably do need to say it. Notice this is okay because g is continuous. Okay, so this limit g of x minus 2 over 3 times x plus 1 squared. I'll say L'Hopital's. I guess there's no essence, circumflex accent. All right, is the limit as x goes to negative 1 of the derivative. That's a g prime of x over, what's that going to be? That's a little annoying. That's 6x plus 6, I think. Yeah. All right, looks like we're getting another issue. If you plug in... Yeah, now we have to say... wow, you actually need to be continuously differentiable. That's a little silly. I didn't actually catch that last line of this problem. Interesting. Interesting. Huh, I wonder what they say about that. But what I'm annoyed by is that this equality here is g needs to be C1 or continuously differentiable. I'll see what they say, and I'll think about it. I'm going to assume it is for now. And this is g prime of negative 1. What's that? You can use the formula dy dx. If you plug in negative 1, that's negative 1 squared minus a half times y, and y is 2. Which is 0. Good, that's what we wanted. Because the bottom is still 0. 6x plus 6 is 0. So you can use L'Hopital's again. So this is justifying this L'Hopital's up here, and then this one's justifying another L'Hopital's. Limit x goes to negative 1 of L'Hopital's of g double prime of x over 6. And that is wow, they're assuming it's C2. Does it say this? Okay, they're actually saying it's C2. That's weird. So it needs C2 here. C2 means twice continuously differentiable. Anyway, it's g of negative 1 over 6, which is, g double prime negative 1. And then you can actually calculate that. I'm really running out of space here. Here's a long problem. That would be if you plug it in to your d squared y dx squared, which is up here. that's -2 plus 1, or minus 1. So wait a second. Yeah. -2 minus 1, so -3, and then plus 1, so -2. Jeez. All right, I gotta check that one because you seem like you need G to be C2. All right, and then D. Let y equal h of x be a particular solution to a given differential equation with h of 0 is 2. Use Euler's method starting at 0 is 2 steps, approximate h of 1. All right, so just give them the tables that they want. 2 steps, so 3 columns. I do 5 rows. You can do a different amount if you want. I do 5 columns. H of 0 is 2, so this is like x, h of x, and then this is dy dx. This is delta x, delta y. Delta x is going to be 0.5 each time. Or I'll use a half. A half. We don't care about these boxes. We want this one. And 0 and 2. And let's recall what dy dx is. dy dx is x squared minus a half y. All right, so here x minus a half y is -1, and then you get -1/2, and then because these multiply to that one always. And you add on, you get a half and 3 halves. Oops. And then you do it again, and it's kind of annoying. A quarter minus 3/4 is -1/2, and then you get -1/4, and you add on, and you get 1, and you get 3 halves minus a quarter. That's 6 quarters minus a quarter, 5 quarters. So h of 1's about 5 quarters. Hopefully I did that right. Easy to make a mistake there. All right, well, I'll check my answers, and I'll see what they say about number C as well, or letter C as well. Let's check. Five quarters is right, -1/3's right. The graph has a relative, yeah, okay. Max at -2.8, sure. Let me just pull up what they said for C and see if I agree with this. That's the right answer, but I'm just a bit annoyed by how they did this. Okay, so they actually checked the limits like they're supposed to. And that was 0, okay. So using L'Hopital's, you can get that one, sure. And the top, yeah, how do they know this? And limit at the bottom is that guy using L'Hopital's again. And then how do they know this one? That's weird to me. I mean, so when you solve a differential equation, you usually are expecting the oh, maybe it's because of that. Well, you're suspecting the solution will be differentiable. Otherwise, it doesn't really satisfy this. But I guess if you satisfy that, you're automatically second differentiable. Is that true? Yeah, I guess you are. And continuously so. I suppose. I really wish they would just like make that clear though. But that's just a nitpick. That doesn't really matter. I mean, it's obvious. It's clear what they want you to do. And it's more like you're hunting for justification for why what you want to do is what you like get to do. For why you get to do what you want to do. All right, I got 5 minutes. I guess I'll keep going. Making good progress today. I feel like I'm like not making mistakes, which I'm happy about. All right, number 5. Some silly cone thing. I'm gonna end in 5 minutes, though I think. All right. The inside of a funnel is given, okay, 10 inches high, cross sections at height, h, the radiuses, whatever. Find the average value of the radius. So literally find the average value of that guy on 0 to 10. That's super easy. You just integrate from 0 to 10, or 1/10, 0 to 10. Let's see, R average. 1 over 23 plus h squared, and then I guess you have to compute that, which makes me not happy. I'll pull out the 120, that's 100, 200th, and then we have the integral is going to be 3h plus h cubed from 0 to 10, and then you plug in, it's times the whole thing, 1 over 200 times the 0 when you plug in gives you nothing, so this is 30 plus 1,000 minus 0, which is 1,030 over 200, and you can cross off one of those guys, and you get 103 over 20. Oh, yuck. Is that actually the answer? It feels wrong. Let me double check that. 3h. Oh, h cubed over 3. What on earth am I doing? Try that again. Very silly mistake. Just going too fast. H cubed over 3, of course. And you get, instead, 30 plus 1,000 over 3 minus 0. And that's really not much more fun. That is 1 over 200 times, that's 90, so 1,090 over 3. 0 still has canceled. This is 109 over 60, I think. And that is not divisible by 2 or 3 or 5. So that's fine. All right. Find the volume of the funnel. To do that one, you just need to add up all the little cross sections. So each cross section is a cylinder, a disc, or whatever. It's a small little cylinder that is dh tall and is r of h wide, or radius. And the volume is going to be pi r squared h, right? So pi r of h squared dh. And then you add them up. The total volume is going to be the integral from 0 to 10 of pi times r of h squared. And that's pi times integral, not pi, 0 to 10. Pi times the integral from 0 to 10 of 1 over 100, 1 over, sorry, 400, 3 plus h squared squared. Oh, this is so dumb. All right. And then this is a really annoying integral. That's pi over 400 out front. And then 0 to 10 of square that, so 9 plus 6h squared plus h to the 4. This is not a fun one. Pi over 400 times 9h plus 2h cubed plus 1/5 h to the 5 from 0 to 10, and that's going to be pi over 400 times, luckily plugging in 0 gives you nothing, so 90 plus 2,000 plus 100,000 over 5 is 20,000, I guess. Gosh, I really hope this is right. These numbers are so funny. They feel so wrong, you know. And it's 22090. So 22090 pi over 400. And that's the same thing as 2209 pi over 40. Is that right? Well, I mean, I'm almost out of time here, so I will just check these two answers and call it good and not do part C. If memory serves correct, that is the right answer, but it's something funky like that. Let's check. This is number 5. Yeah, 109 over 60 and 2,209 over 40 pi. That's what it is. Did they ask for units? No, they didn't. Okay, cool. That'd be it. I guess you can say inches cubed if you want, because it does say in inches. But I don't know. All right, I guess I'll stop there. Thanks to anybody who showed up. I'll try to, I have 2 videos on the back burner already and got 1 more to do, but my life is busy right now, so I do apologize. All right, have a good one. Good luck on your studying. See you later.